So similarly, we have the mirror formula, if you remember. Okay. So in the mirror formula, you use the focal length 1 by f equals to 1 by u plus 1 by v, right? So if we can attach, I think all have joined, right? So how to find the error in the f? In case of mirror formula, we know that f can be positive or negative value, but when you write the relation, okay, whatever the relation you get, first you put the sign in the very beginning. Okay, so if you know u is negative, so put minus mod of u. If you know v is positive, put v, whatever. But generally, the way of writing is this. Okay, you simply write like this. Just take modulus. So we are writing the relative error of each term. And the third term you can rewrite as so you can find the error like this. Okay. We have also done the so in current chapter we have done this for the Wheat-Eastern bridge, sorry, the meter bridge, right?
Yes,
if you remember. So that I will not repeat. Okay. Now there's something called velocity of sound in case of a resonance column method, right? This is important. Velocity of sound in air by resonance column method. So in this case, what we do? We find the resulting frequency by emptying the or lowering the water level, right? So let's say at a depth of L1, you get the first resonance, the whistle sound will come. Okay. And then again at the next level, you get the next whistle sound at the 2 level of the water level. And in the first case, we have the end correction, if you remember, right? And the second level is so L1 plus E we write as lambda by 4. And L2 plus E will be the 3/4. You can think this way. It's not a correct diagram. This is lambda by 4. And from here we got to E equals to. And from here we got lambda equals to and the tuning fork having frequency f, so the velocity of sound is f lambda, and therefore we got the formula. Now to find the error in the velocity of sound, del v by v we can attach. And this you can rewrite as, this is called the del f, f you will get as the tolerance of the tuning fork action, which is normally mentioned. Error of difference is how much, guys?
Sum of errors.
So this is how you find the error in the velocity of sound. I hope this is clear.
Yes, sir.
So imagine if I give you some numerical value, and this was a JEE question. So let's say L1 you got as 18.0 centimeter. L2 was given as 78.0 centimeter. Okay, and the tolerance is given 2%. Okay, and let's say the frequency is. I need to take some nice value, but anyway, let's say tolerance is given. So what is the percentage error, or you can say fractional error in the velocity of sound? So we can directly convert the tolerance as 2 by 100, the first part. Now the problem is that delta L2, delta L1 is not given. But can you guess the answer from the values given? You can check the significant figure after decimal. It is only 0.0, right?
So 0.01 will be there.
So the answer is 0.1. Because the least significant digit is the rightmost.
Okay.
And the leftmost is called the most significant digit.
Yes.
So uncertainty is always associated with the least significant digit, isn't it? Hello?
Yes, sir.
So when you go to a petrol pump and when you start filling the fuel, the petrol, you can see the least significant digit moves very rapidly. In fact, you can't read it. Then the next digit will move after some time, and next will move very slowly. Have you seen that? Hopefully.
Yes, sir.
So the least significant digit will decide you can say the extent of error. So the error here is possible is 0.1. That's it. So if it is 18.00, I will add 0.01. If it is 18.000, I will add 0.001. So that's how we write. And that is why the answer is 0.1 plus 0.1 upon L2 minus L1. So it is 2 by 100 plus 2 by 60. So whatever is the answer. 60. All right. So this is the answer. I mean, you can convert eventually. Yeah. The next is very famous. Simple pendulum. So in case of simple pendulum, we have something called point of suspension. Then we have a length of thread. And the length of thread we write by the symbol capital L. Then we have a bob. It is, I'm going to use very small, but it's anyway. And the radius of the bob is R. Okay. And there is something called center of mass of the bob. So the CM of bob is here. So the distance between the center of mass to the point of suspension is called length of pendulum. So L is called the length of pendulum. And for your information, L is not the length of thread. So how you suspend the thread if it is touching the surface, the L is certainly not the L, but because R is very small compared to L, we take a roughly equivalent. So if R is very small, it's negligible, then L you can take as the length of thread. So it is a very common misunderstanding that the L in the simple pendulum formula represents the length of string. No, it represents the length of pendulum. So the time period is how much? So time period is 2 pi under root. It is L by G. It is not capital L by G, which you can roughly write as. So time period is something which we can measure using the stopwatch. L we can of course measure using the meter scale. So the purpose of using this formula is to determine the value of G. So how to write G roughly? You can square both sides. So 4 pi square L by T square. So can we write like this? Tell me guys.
Yes, sir.
So now you can see we have some constant called 4 pi square, but we have terms which are either multiplied or divided. So the delta G by G mean, can we write like delta L mean by, and 2 times delta T mean by T mean. Okay.
Yes, sir.
In examination, they will not give you the time period. They will give you the time of observation. So how they mention? They'll tell you that, see, you can't find the time of one oscillation, but you can find the time of, let's say 20 oscillation or 30 oscillation, because that's quite a good value. So delta T by Tm, we can also replace. So let's say delta T is the time, not like this. So let's say T is the time period for n oscillation. Now, if you are using the stopwatch and if you make the 100 observation, or let's say 50 observation or 30 observation or 20 observation, the least count of the stopwatch, if I say 1 second, so 1 second represents what? Delta capital Tm or delta T, small t. So delta T is actually the least count of the stopwatch, and that will represent the n oscillation interval, right? Not for one interval, isn't it?
Yes,
So
sir.
there's a relationship between these two. So generally, we don't know the time period for a single oscillation, but we can, of course, write. So how we can write? Delta T, can we write this as delta T by n? Because for n oscillation, this is the error which you read on the stopwatch. So what is the error per oscillation? Delta T by n. And what is the time of period of oscillation? And because n will come in the numerator and the denominator, so n gets cancelled. That's why to solve question, the time period is not required. What is required is, if I can act like this, it's nice. We take the time of the all observation taken, yeah, all observation taken together. Understood?
Yes, sir.
So once you convert something like least count per oscillation, you have to change the idea like this. And once you know delta L, delta T, you can get the answer. Okay. The next. So there was a question in JEE Advanced long time back. Okay. And there was a well, and everyone got the right answer. And most of them applied the wrong formula. But luckily, all got the same answer. So those who did the hard work and those who did nothing, all got the same marks. Nothing wrong in it, but what is wrong is the you are supposed to understand. So you drop some, this is the water level, let's say, and then you drop some stone. It will fall, freely fall, correct? And after free falling up to the depth h, it will make the splash or hit the water surface, and so a sound will travel with its speed and will reach the observer. Okay. So how much time it will take to listen to the sound? So it will take under 2h/g to hit the water surface, and then h/v will take to reach the what? The observer again.
Yes, sir.
Understood? And therefore, what is the error in the measurement of all these things? Let's say we have some error. So d of t will be d of 2h/g and d of h/v. Okay. And let's say g is constant. So here we have to find the dt relation with h actually. So assume g is 10 meter per second square. H is 20 meter. In fact, the dt is given. V is 300 meter per second. Find dh. What is the error in the height calculation using this relation? So what is the height calculation? I'm sorry, the error in the height calculation, not the height, of course. Height is given. The error they ask. So to solve question like this, where you see there are two terms which are one is, so it's a like power relation, isn't it? Am I right? If you remember this power relation, from here directly you can think. So what is interesting here, that dt is error, but the term here is we have something constant and something in error calculation. Every term which is constant we can ignore if we write the, what if we write the relative value, if you remember, isn't it?
Yes.
All right. So how you're going to write this, all the terms? I mean, the dt equals to, so 2/g, you can take under root. What we are left with, t of root h. You can differentiate by the simple formula. V is constant, so we can write as dh/v. So we're not writing any error. And now what is interesting here? How to find this term? Because that's the problem. This term is okay. It's simply 1 by V outside, DH is the DH. What is D of root H?
Of each.
So DH of root H is. So we know you can think, okay, this to solve this, you can think, well, let's let Y equals to
DH by
root H.
DH
If
by
Y
2.
equals to H, so dy, the fractional error we can attach 1 by 2 DH by H. Isn't it?
Yes.
Because this is what we have studied. Now, fractional error in the Y equals to 1 by 2 times fractional error in the H. That's the power rule. That's the power rule. Isn't it?
Yeah.
So basically, dy is how much? Y by 2 DH by H. And Y is how much?
Root 2. Root H. Root H.
You know what is the answer? Okay, anyway, you know this answer. So basically, this term we can rewrite as d of root h, which is dh by 2 root h, right? Isn't it? D of y means what? D of root h, which is dh by 2 root h. Anyway, that's a relation which we know. Plus, so now you can see dh we can take common. 1 by root gh. 2 to cancel. No, this 2 will not get cancel. Okay. So 2 by g for each. So dt turns out to be dh into 1 by under root 2 gh plus 1 by v. And now they have given everything here. So dt is given how much? So dt is given 0.01 second. And 1 by 2 root h, 2gh, which is 2g, 2g20. H is how much? 20. Oh, that's nice. And v is given. So 1 by 20 plus 1 by 300, how much? It's 300 LCM. And then 15 equals to 0.01. Plus 116. Yeah. So DH turns out to be how much? Three by 16. Tell me, guys, is this correct? Correct?
Yes, sir.
What is the DH by H value? What is the fractional change of H? H is given 20. So percentage height error is how much? Percentage error is how much?
Into 100.
So the answer is 15 by 16%, right? So numerically it is close to 1%, right?
Yes.
And the answer was 1%. See, people who have not done this rigorous calculation, they only use the DH by V, the other part. I mean, and all got the same answer because the answer was coming near to 1% only. So this was the NT, I mean, sorry, NNT question, the numerical answer type. So, okay. All got the same answer. Anyway. Okay, the next question is calculation of a relative density by concept of using concept of buoyancy. So if you summarize something completely, let's say we have a spring balance and with the help of this spring balance, you suspend some mass of density D in a liquid of density rho. The spring measures what? Spring only measures the tension developed, right?
Yes, sir.
It has nothing to do with the bond force, whatever, or the weight of the object. It only measures the tension. And if you do the ABD, so the tension is acting upward, mg will act downward, and the force of buoyancy will also act upward. And so you can say T plus force of buoyancy equals to mg. For fully submerged object, for fully submerged object, the force of buoyancy is mg into, so you can say write like this, V rho g, you write as V rho g. So volume you can write as m by d. This is the entire volume of the object, V rho g. So you can rewrite as mg into rho by d. This is the bond force. So you can write as mg into rho by d. Okay. So T turns out to be how much? Mg common 1 minus. Okay. So T is called the apparent weight. Mg is called the true weight. And density of object upon density of a liquid is called a relative density. So if you look carefully, the formula will be W apparent equals to W, which is the actual weight. If you want to connect AC, 1 minus 1 by a relative density. So to convert this into a nice format, let's call this term as X, this term as Y, and I would like to measure the Z value. So we can write Y by X equals to 1 minus 1 by Z. So 1 by Z equals to 1 minus Y by X, X minus Y by X. So Z is finally. So Z is basically true minus apparent, right? So the true upon true minus apparent is the relative density. You may get question on this formula itself because this is really nice. So what is the error in the relative density? So dz by z equals to, right? See, unless you're not getting the parallel grouping formula anywhere, stick to this method. For parallel grouping, use the differentiation method, the NCRT method. This. Oh, that's in the last lecture. Okay. So error in the relative density is what? The relative error in the true weight plus the sum of error in the true and the apparent. And then the denominator is what? True minus apparent weight, right? So given the error in the true weight, apparent weight, can we find the error in the relative density? The answer is yes. We can find. Okay. So this is one question that will come across. The next is the Searle's method. And this is the most important part from the error chapter. Okay. So in the Searle's experiment, this is from the chapter of elasticity, if you have watched that lecture. So in the experiment, what we do, let me recap the Searle's method of determining the Young's modulus. So Searle's method to determine the Young's modulus. Okay. So what we do is we take two steel wire of same length. So is it possible to hang the two thin steel wire exactly straight? Or will it bend if you hang? So if you hang, what will happen? Will it bend or will it remain straight? So generally it will bend, right? I don't think a thin straight wire, wire will be perfectly straight. So to make it straight, what we do?
Bend in the sense,
I mean slightly left to right, whatever.
sir, why will it do that?
Let's say you're taking the wire, it was wrapped around some coil and then you cut a piece and then you're trying to make it straight. So generally,
Oh.
if you're purchasing from the shop, you won't get a straight wire like out of the factory. So generally it is coiled, right? Before it is transported, isn't it?
Yes, sir.
And you get a piece of that wire. And if you try to make a straight by pulling by hand and hang it, it will again bend because it was earlier bent. That's the reason. Okay, of course not. It can be perfectly straight if it is maybe manufactured and without before coiling, you're putting it here. Okay.
Okay, sir.
All right. Now, what we do is to make the wire straight, we hang two masses of equal value on both the wire. So you start with the equal length and then you also attach equal mass so that the elongation in the first wire and the elongation in the second wire remains same. Therefore, the final length of the wires are same. Now, what we do is in this experiment, we choose two wire because one wire will act as the standard wire. So we call one wire as the standard wire. And the other wire we call the load wire. So the load wire is the wire on which you keep on putting the load and you will try to measure the extension. Now, the standard, or you can say the fixed wire, is attached with something called vernier scale. Have you heard the name vernier scale? So there's something called vernier scale.
Yes.
If you have not seen, let me know. First, I'll show you the vernier scale on Google. So vernier scale is a part of vernier caliper. So vernier caliper is a device name or name of the instrument. And a vernier caliper will have two separate scale. So one is a bigger, you can say, scale, the long scale, which is kind of fixed. And there is a movable part. Okay. So the movable part is called the vernier scale and the fixed is called the meter scale. Generally, this is the terminology which we use, or the main scale. So we call it the main scale. The main scale is kind of fixed. And you slide over the main scale at again a small piece of scale. And that is small piece we call vernier scale. Together we call vernier caliper. Okay. So the vernier scale or the VS scale is kind of fixed. Okay. Oh, my bad. So this is not the moving part will have the vernier. So the fixed part is called the main scale. Why main scale? Because the main scale is kind of fixed. It will not move at all. And the load wire, the wire on which you are going to put some load, will contain the slider. So in the very beginning, you keep the 0 of the main scale and 0 of the vernier scale coinciding. But as you put more load here, the 0 will come down, isn't it? So 0 will come down. And we have different calibration on the two scales. So the meter scale will have slightly bigger calibration in general, I mean, not necessary. Whereas the vernier scale will have slightly narrow calibration. Now tell me which scale will have a smaller reading value, vernier or main scale. The calibrations are closer in which case, in general?
Vernier.
Vernier scales.
Vernier.
So vernier scale will have the smaller, you can say, calibration. The main scale will have bigger calibration. So if main scale is fixed, because the loading will not make the wire extend by large value. So it will always move fraction of a millimeter. So for human eye, it's invisible. You won't be able to see, but the vernier scale slightest movement will make the mismatching of zeros. And once the 0 will not match, there is a problem. No, there is in a way solution actually. The mismatching will let you actually know how much it got extended. So we'll see that, how we exactly perform. So think of two scale. Let me put side by side. Okay. And then let's put the calibration also. Okay, and so on. And then there is a calibration here also. So because of unequal calibration, some calibration on the vernier scale will coincide somewhere on the main scale, but not always, right? Okay, anyway. So how everything is performed, what are the terminologies that we need to know or use? Okay. So the extension in the length of the rod, I mean the wire, we use the vernier scale to do the calculation. But we also need to know the diameter of the cross section of the wire. Now diameter is very small. If you think of a wire, you can understand how small is the diameter. And therefore, to measure the diameter, there is another device which we use called the screw gauge. So have you all seen the screw gauge? So in screw gauge, we have a
Yes.
rod and we have a kind of again slider, but the slider will rotate and move. So it will not just free flow left and right. It will turn and it will move as you have seen the movement of a nut in a groove. Have you seen? So you rotate and it goes down and up, right? So we have some sort of helical, grooving in case of big screws. Have you seen that grooving? And because of the grooving, as you rotate, it goes up and down. Okay, into the you can say nail, the screw actually. So we have a screw gauge, and the name is screw because it's a screw, a rotating screw actually. So here we have a thin rod, and over this thin rod we have a slider. So I'll just draw this a simple model slider. If you want to get the experience, the real experience, just please look at the screw gauge in Google picture. This is the cross-sectional view. So this part, if you rotate, so this is basically a circular scale. So as you rotate the slider, it will slide left or right. And the way, if you see the design, and the slider will be touching this part. So you will keep no gap in the very beginning. So as you move the slider, it will leave the gap, it will go this way. So if you move anti-clockwise, so if you look from this side, so how to rotate the slider to open the gap? Clockwise or anti-clockwise? Tell me.
Sir, anti-clockwise.
Correct. And so to close the gap,
Clockwise, sir.
so to put the wire between you, pull it, you turn it anti-clockwise. You create some gap, you put the wire, then you tighten it, and then you see something to make the reading. Okay. So this circular, the screw which you slide over this rod, this is called the circular scale. And again, this is called the main scale. In vernier caliper, this is vernier caliper. In vernier caliper, the smaller one is called the vernier scale, the bigger one is called the main scale. And again, the vernier scale is like a slider. It can slide left, right. And again, we have the similar gap kind of thing. So we have I mean, I don't know how it is, but as you move, as you slide, it can come close and then go away. So this is attached to the vernier scale. So what happens? Let's see this vernier scale. So can you see the screen? Don't buy it. It's industrial. You can see this, the main scale, and this is the slider part, which is screw. Can you see this?
Yes, sir.
So this will slide. You can see if you just move the slider, the gap will converge. These two gap will be zero. If you move towards left, isn't it? And as you pull back, you will create the gap here. Do you see this? And you
Yeah.
can see there's a zero in this, in the main scale. This is the main scale, the middle one. You can see zero here. 0, 10, 20, 30, you can see. And it goes to here. Okay. Look at this part, the slider part. You can also see zero here, 0, 5, 10, 15, 20, 25. Okay. But there's one more interesting thing you can read here. You can read something here. 0.001 meter, I think, or millimeter. 0.001. Okay. Now, when you read
Sir,
the number,
inches.
inches, yeah, 0.001 inches. Now, what is that? 0.001 inches. So 1 inch is 2.54 centimeter. If 1 inch is 2.54 centimeter, so what is 0.001? Anyway, I'll tell you.
0.002.
Yeah. What you need to understand is that the cutting, okay, the way you make the calibration on this scale, the numbers are very misleading. I mean, you cannot understand that this 0 and the 10 and this 0 and 10, that 0 and 10 on the slider and 0 and 10 on the main scale are the same values.
No.
No.
They are symbolically numbers by same, but they represent different values because the calibration is differently gapped. So the gap is different. So they have different variation of gap. Okay. So a typical vernier scale, you can see it's below. The below one is the basically vernier scale. A typical vernier scale will be slightly smaller. I mean, typical means the regular what we use. So the 9 such calibration, the 9 division we call, the 9 division of the main will be equivalent of the 10 division of vernier. So vernier 10 division is actually equivalent of how much main scale division? 10 division. That's the engine. But again, there is no need to mug up this answer. J will create something new. What does it mean is, let's go back to our actual. Okay, let me show you some screw gauge. Just a minute. Yeah. Oh. So can you just see the screen now? A new screen.
Yes, sir.
So you can see if you have a spherical objective, if you want to place between the two, so the rod which is passing through the inner part. So as the circular scale, which you can see the number is 15, 20, 25, 30, you can see on the right. As you rotate like a screw, it will slide backward and forward. So if you look from the rasher side, the last side, then anti-clockwise will open it and clockwise will close it. That's simple. You can also see something like called a datum line or center line. Do you see that? So
Yeah.
that is your main scale. And now you can see you can make some reading. Okay. So here you can see you can read this number, 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 this number. But you can't read what is next number, right? So this is called the reading of the main scale up to here. So this is the perfectly read value. This is main scale reading. So if I put some number 0, 1, 2, 3, 4, 5, 6, 7, 8, and then ninth I can't see. Do you see the ninth, the next line?
No.
So when you don't see, you say this is uncertain. So that's like that will be read separately, not on the main scale. So the remaining part is not read on the main scale where we study on the circular scale. So what we do next is from the datum line, we check the matching number of the circular scale. So in this case, it seems to be something 22, something, let's assume. So from the datum line, which number you can see from the main scale? Okay, some number you can see. I don't know. So generally, what is there before the opening part? If it is perfectly close, what you will see the matching part? The datum will match with the O. O means 0 of what? The circular scale. So the 0 of the circle will match with the datum. So as you rotate anti-clockwise, which number will start appearing near O? A
9.
number more than 0. Okay. So as you turn, this will become 0, 5, 10, 15, 20, 25, 30. Let's say if it is a 100 scale division, if you make 100 small cut on the circular part, then it will go from 0 to 100. So exactly below the 0, what will you see the number? It is 100. If it is 100 is, 100 division. Sometimes we use 50 division circular scale. It will have 50 such cuts. So below the 0, we'll see 50. But 50 should come after one rotation almost, isn't it? So the 0 should match with the datum when there is no measurement. As you start opening it, the 0 will shift somewhere. And as per the movement of 0, we can also do the measurement. I'll tell you how. Yeah, that's still.
Sir, will one rotation of the circular scale always correspond to one division on the main scale, or can it vary?
Yeah, it can vary. That's a very interesting question. So
Oh.
the idea is by default, if nothing is given the question and there's no implicit way to determine, it is believed that one rotation is equivalent of one pitch, which is equivalent of one division of the main scale. So by default, the rule is we must take only one division of the main scale per rotation. But it is quite possible that JEE will ask you the question in which it will mention that one rotation will slide it 2 units away on the main scale.
Because I had encountered a question where it was not clear whether they had given some values, but it was not clear whether one rotation corresponded to 1 millimeter or one division. So
One division, not millimeter, one division.
okay.
And division you must convert into unit. See, the
Okay.
word division means the numbering. 1, 2, second, third division. Division is not the value. Division is only division. To understand the value, you have to know the length of division. What is the unit of division? Okay.
Yes.
So we use this terminology that division and the length both are different. Okay, they're not same, and it is easy to get confused. Okay, so I'll go back to the theory now quickly. Just two theory, one scale and screw gauge, and we're done. What is this? Okay. I think this is too late. I think you all should go. I'll just teach. I'll finish. You can watch it later on. It's actually too late. So, anyone wants to stay? I will not force. I mean, this is like voluntarily. Okay. So how to study? Okay, first of all, what is the search method? Yeah, tell me.
Sir, still, like how much more time?
I don't know. It will take some time. I mean, there are 2-3 pages. That's it. You should leave actually. I mean, don't stay so long. Just watch the last 1 hour. I'll share the videos. Okay.
Okay, so
Okay. So you all can take a rest. I think Dars can stay. Okay.
So are we continuing then?
Yeah, I'm going to continue. Even no one is there.
Okay,
I'll
sir.
finish it and then you can read. Okay. All right. So shall I continue?
Yeah.
Okay.
yes, sir.
So we have a main scale. So we'll start. We start. Okay. Wait, I'm confused. So for the search method, what we do is there's a definition: stress equals to Young's modulus into strain, and stress is defined as load upon area. Young's modulus by the symbol L, symbol Y, and the strain is defined as the change in length upon original length of wire, of course. And the load we write as mg. Area of the wire we can write as pi r square. And then we write as delta L by L. So what is y equals to? As a formula, y equals to mg capital L upon pi r square delta L, right? So if you're trying to measure the L we measure using the meter scale. But how we measure the elongation? The answer is vernier scale. So this term we use vernier caliper. This we use meter scale. And this R we use, we don't measure R, we measure the diameter. And what we use for the R? So for R we use screw gauge because R is really small. So vernier is not sufficient to do it. And why this experiment is so famous among all this error analysis chapter? Because this is the only question in which all scales are used simultaneously. So when it comes to the search method, you need to know the error in the, I mean, using the meter scale. What is the least count of meter scale? You should also know the least count of vernier scale or vernier caliper. And you should also know the least count of screw gauge. If you know the screw, I mean the least count of these three devices, then only you can solve for the error in Y. Okay. So to solve as an error problem, the Y is rewritten as M, G, L, and the R is not a measurable quantity. We measure the diameter using the screw gauge, because when you put the wire between the two end, you can only see the diameter, right? I mean, you can only see the gap of diameter, the length of diameter. So we can add D as D square by 4, R as D square 4. And the delta L is not written actually. Rather, we use a small L, which represents the elongation part, where L itself is delta L. So elongation is the value which you measure. So we always try to convert the value measured into a symbol so that we can also find the error in that value. So delta L is elongation, which you find using the vernier caliper, but the error you will also get, which is the least count of vernier caliper. So finally, we can add to Y equals to okay, so there are two ways of writing mgl by pi r square L. But we prefer writing in terms of diameter for solving question. So now, what are the things which are constant? Generally, we take mass as constant, and the error calculation which you will study. So L is also taken as constant, and most of the error calculation you will find is in these two terms: the vernier caliper and the screw gauge. Okay, so how to write? Taking everything else as constant, mgl. So take mgl as constant, and in constant we don't find the error. So we write the Y is k upon d square L. It's just inversely proportional to these two terms. And therefore the fractional error, how to write the fractional error? The dy, or you can say del Y by the fractional error in the Y will be how much? I hope it's easy to understand. It's 2d by d and del L by L. Am I right, guys? We always add the error.
Yes, sir.
Now the delta L is the error in the calculation of L. L itself is elongation. So delta L is called the error in calculation of elongation. And how we measure the error in the elongation? So this is the least count of which device?
Vernier.
Vernier caliper. Is this clear? So what is delta D? Error in calculation of diameter of the wire.
Yeah.
So this will be least count of
Screw gauge.
screw gauge or micrometer. We use both the device,
Okay.
or you can say micrometer. So of course there is some difference. Micrometer is for the different least count. So they are known by the least count. So micrometer will have, I think, 0.01 millimeter as the least count. Vernier caliper will have 0.1 millimeter of the least count. And so the typical screw gauge will have the same. And it is for micrometer because I think its least count is micrometer. I think that's right. Okay. Anyway, I mean, for me, everything is screw gauge and everything is a formula I can solve. So after understanding this terminology, you can actually use the vernier scale to decode the answer. How we do the measurement, I'll tell you. So I'll make it really simple. So draw the meter scale. And imagine on the meter scale we have one number, which I don't know which number. So generally what I name it, I call this as number n, and the number n plus 1. This is the calibration, the division part. Okay. All right. So
Yes.
where is my 1 year scale? It is fortunately in between these two numbers. Okay. Then now listen carefully. What is next? What is happening here? You can clearly see the measurement of the meter scale, main scale. What is the main scale reading here? So main scale reading is n division. See, I'm not writing the value. N division. Let 1 division of main scale equals to AM. So what is the main scale reading in value? NAM. Understood what I'm saying? Division is not the reading. Division is only division. So main scale reading is n division, and n division is equivalent of how much value? NAM. What is AM here? You know what is AM? This is AM, the numerical value which is known to you in centimeter or millimeter. Understood? Hello, hello. Anyone there? All
Here, here.
no. So AM is what? It is the length of 1 division of main scale. Length of 1 division of main scale, which is also called, so AM is also called least count of main scale, isn't it?
Yes.
Yes, sir.
Because you can't measure less than this. So this is the least count of main scale. So let's define similarly something. So again, we have the division on the vernier scale. And I will just show you one division which is particularly interesting. The division on this vernier scale is coinciding with one particular, okay, just let me do this. Yes. So imagine some random division called the kth division. Okay. Of what? The kth division of the vernier scale is coinciding with some random division of the main scale, which I don't. So the rule is when you see when the zero of the vernier scale is somewhere here, some division must be matching. You have to read where it is coinciding, and we call kth division. So let kth division of vernier scale is coinciding with some random division of main scale. So it is not important. That's why it's not given. So far, these are the terminology. So I will use one more terminology. So in a vernier scale, also there's a gap between the two divisions. So let's call this division, this gap, by a name AV. What is AV here? Can we say AV is the least count of vernier scale? Can we say? Okay. Tell me, guys. Can we say?
Yes, sir.
Okay. So if kth division is matching, then can you tell me what is the length between the kth division and this end of the Vernier scale? This length is how much? Any guess?
A times AB.
K times A. Very good. Very good. So what we are missing actually? This extra part, right? So we know the reading is, this is the missing part. I don't know what is this answer. How much is this? How to get this answer?
Sir, I guess N times AM minus K times AB.
Pardon?
NAM minus KAB.
Yeah, it is N. Go ahead.
AM
N M
minus KAB.
minus K. Okay. Yeah. So it is NAM or it's a KM.
Okay, KAM, yes.
So it is let's say the kth division on the Vernier scale considered with any division on the main scale.
Hmm.
So what you said is correct. It's a KAV. Okay.
Yeah.
And the X, if I add X plus KAV, what will be the answer on this side? So generally the the division of the Vernier scale is slightly less than main scale. Okay. Okay, so the question is how to get this extra X. I mean, this is the missing part. If I know this answer, then I exactly know my actual rating. So what is my actual rating? Tell me what is the actual rating? The actual rating is NAM. I hope you can understand. Plus X. Isn't it?
So,
Yeah.
sir, can you just explain this with an example?
Yeah. Once we'll finish this numerically, then I'll explain with the example. I'll give you some info. So first you
Okay,
need to understand that reading is what? See, reading is up to the O of the Vernier scale, right? Where the zero has, sliding.
yes, sir.
So earlier zero was constantly here.
Yes, sir.
Now zero is here.
Yes, sir.
So what is the reading? So reading is N times AM, the reading up to this value, plus the X extra. And
Yes, sir.
this length we know. This length is NAM. So N division is the perfect reading which we can read on the main scale, isn't it?
Yes, sir.
So what we are not able to read? Can you guess?
The X part.
The X is not able to read. So we have to find X now, somehow.
Yes, sir.
Because once you get the X, your job is done. So your reading is actually NAM plus X, right? That's the only thing. This we write as main scale reading plus this called
Vernier.
VSR, Vernier scale reading. And to read the Vernier scale, let's say if the kth division is coinciding, okay. So beginning from how to say this, the X plus KAV can be written as equals to KAM.
Sir, but how is AM related here?
That's interesting. So, okay. Okay. The kth division is coinciding with any division. So why this is happening? You have to go into the practical aspect of this. I have shown the AV really small. Okay, that's the biggest problem. Okay, I need to change that AV part. You know, when if you this see the AM length, AV will be slightly smaller, not very much. So we believe that if you start from N and if you move K division ahead, then only you will also meet the Kth division of the vernier scale. Once again, this is important. What is happening is this has to do with the practical aspect. The vernier scale division and the main scale division, the gap is not much. So one division of vernier scale, if it's this much, the one division of main scale will be slightly more, or it will be either slightly less. So the main scale and vernier scale cannot differ by even 1 unit, which means none of the division can contain 2 division of the other. Are you getting my idea what I'm saying? None of the division will keep 2 division of other. It means one main scale division and one vernier scale division. If you take the ratio of this ratio of the lengthwise, then ratio will be either you can say it is close to 1 point something of fraction, or it will be 0.9 something. So the length of division, they are only slightly different. And the question is why they are slightly different. Can you guess why they are slightly different?
So that it's like n divisions on the vernier scale can correspond with n-1 divisions on the main scale. So every division can get a corresponding division to coincide with when we are measuring
Yeah, so
something.
see, the whole purpose of designing some more accurate instrument is to get a smaller reading, smaller reading, right? So if I keep the two gap really small, then the difference will be very small. Let's
Yes.
say your length is 1 millimeter, my length is 0.99 millimeter. So what is the difference between these two lengths? 0.01
1 mm.
millimeter, isn't it? So by keeping the gap very close to each other, we actually create a smallest possible difference, isn't it?
Yes.
And because of that, when kth division of the vernier scale will coincide, so beginning from this, you can say pole position or this reference or datum, if you move k units, you will exactly land here. So k of AM from this end and k of AV from this end will coincide.
Because of the negligible difference.
Yeah, which is negligible difference, which is very small.
Okay, understood.
And that is why the reading of X is very easy. How you can read the X? It is K times AM minus AV. Do you realize this?
Yes.
I think Hasika is not understood this. Still you're finding this difficult to digest?
Sir, I sort of understand what is happening here, but I'm having a little bit trouble
No.
understanding how it is
Yeah.
happening here.
No. It's like, see, this is here actually. You slide till here. So your edge of the vernier scale it falls here once you pull it back. And if you
Yeah.
remember the vernier scale, you know, the shape, the jaw was moving away from each other.
Yes, sir.
So one is the fixed jaw, and other is a jaw which is attached here actually.
Yes, sir.
So as you move it backward, the jaw will wide open.
Yes, sir.
So my object must be somewhere here, isn't it?
Yes, sir.
Because my object is between these two wide gap. Try to understand. This is the measurement. This is the reading.
Yes, sir.
So what is my reading here? It's n times am plus x.
Yes, sir.
The n times am is called main scale reading because I can read n clearly, right?
Yes, sir.
Because the zero of the vernier scale is between n and n plus 1th division, which I don't know what n plus 1. It could be 2 or 3, 3 or 4, 5 or 6, 7 or 8, whatever, right?
Yes, sir.
So now the question is how to find the x, because I can read NAM up to here only. No? So
Yes,
what
sir.
I'm not able to read the x value which I'm missing.
Yes, sir.
Okay. Now the question is how to get the x value. So what I said here that practically the vernier scale division length and main scale division length, they do not vary much. They are slightly different, very close to each other. So when I say the kth division of the vernier scale coinciding with any division of the main scale, which means the kth division from the zero of vernier scale and the kth division right from this end to this end, both will have the
Yes,
k
sir.
divisions. Both will have equal divisions, k divisions. But for the main scale, the calculation will start from n, and for vernier scale, you will start from here. But both will contain same number of division.
Okay,
So
sir.
the
So,
number
the
of division from
spacing, sir, so like the individual spacing is so minute that wherever it will
correct.
coincide. Okay, sir.
On the
Yes,
vernier
sir.
scale, it will be same for the main scale also.
Yes, sir.
The only thing is the difference will be as per the reference line for the two scale. Okay.
Yes, sir.
And see, the whole idea of designing the vernier scale is to take the difference of the two scale values to create a further lesser value. And that is why now comes the definition of least count of vernier caliper. The vernier caliper is a device name, the entire thing. And you can clearly see the difference of the length of main scale, like the least count of main scale and the least count of vernier scale. If you take the difference of these two values, then what you get is called the least count of vernier caliper. So this is called least count of vernier caliper. And that's why the way if you read in book, they mention least count as a formula directly. They don't never mention how it has come. They will say this is the formula. What is the formula? 1 MSD minus 1 VSD into, I mean, you have to express in value. So 1 MSD minus 1 VSD in value. So what is 1 MSD? You know, it's a length of, I mean, some value of the main scale division. What is VSD? Vernier scale division. And the difference of the two length in value term, when you subtract in value, what you get is called the least count of vernier caliper. Understood? So
Yes, sir.
now that's why if you read the any textbook and if you see the formula, they write as the answer is main scale reading plus the coinciding division of the vernier scale into least count of vernier caliper. This is now the formula which you have to use. But the reason behind the formula I have explained, because in JEE advanced, they have asked question in which you cannot apply the formula. Why? They changed the scenario. They made the VSD bigger than MSD. Slightly bigger. But this method will work everywhere. So anyway, so reading is main scale reading plus K times least count for a general purpose vernier caliper in which MSD or always exceed the VSD. If I change the scenario, I have to do it from scratch. That's why you need to know the process, how to do this. Understood what I'm saying?
Yes.
And now they will mention something like this. Okay. So this is just like a way of understanding. They'll mention something like this. N, or you can say M. So N main scale division, if you take N division of main scale, it is equivalent of M vernier scale division. That's logical. Like if they are not equal length, so the different count of the length will make it equal, isn't it? So if I give you two scale, one scale is bigger, other scale is smaller. So you have to take different number of such scale to make equal length, isn't it? So that's why we say if the N main scale division is equals to M vernier scale division. So generally we prefer to write the answer in terms of main scale division, and therefore the length of one vernier scale division will be N by M into the length of main scale division, isn't it? So what is my least count of vernier caliper? The answer was 1 MSD minus 1 VSD, if you remember, isn't it? And because we do not know the VSD length, I'll convert it into MSD. How to write? N by M MSD. And so my answer is 1 minus N by M. What is MSD here? AM, right? Sometimes you need to express the answer in terms of VSD because they mention VSD, not the MSD. So how to write the answer in that way? If you want to express the answer in terms of VSD, let's change the way of writing.
M by N minus 1.
No, it's a M by N. No?
Yes.
Yeah.
And then it will become
AV.
AV. Now, this is the way to understand that in different scenarios, especially if you look at the JEE advanced question, they have played with all these ideas, every idea which I'm sharing. Okay. And they know that, okay, if you know the formula, if any student knows the formula of vernier caliper, they will not be able to solve any of these questions because you need to actually understand each bit of it, how to understand AM, AV, the way of writing the least count, and how to write it. Okay, so depending on the question, you have to always think from scratch. Now, typical question of mains, I won't say will be that difficult, but advanced certainly. And in JEE advanced, you know, they will always ask question from the vernier caliper and screw gauge for sure. Okay. So just remember the idea, like how I'm deriving the answer. Say, am I using any formula? No, I came to the formula in the end that this is the formula which you have to use, which is generally written in the textbook, but the measurement is simple. And there is some practical aspect also. The difference of the two divisions are very, very, very small. That's why when I say the kth division will coincide, it will coincide for both the scale, vernier scale and main scale, but the reference will be different, right? So for main scale, you start from the last number which you are able to read, N, and for vernier scale it is from 0. So I hope you will be able to recall some of these ideas while solving numerical. Okay, I think I need to show the numerical, then only you will be convinced. So what I'll do is I'll finish the screw gauge quickly and then we'll go back to the some numerical. I think this is too late now. Even I'm finding this stage. Okay. So shall I finish the screw gauge also? Leave it. Maybe sometime later. Tell me. I can teach till 4 o'clock. I have no problem.
Sir, here Oman time it is like 1:30 only.
Okay, so you can stay further.
Yes, sir. Sir,
Okay.
but what about you and Darshan,
No, no.
Tanashi?
I'm okay. I will be awake till 6 a.m. actually. So I will sleep around 7 a.m. Then I'll go to airport at 9 a.m. Will sleep in the plane for 2 hours and will reach my village actually in the evening.
Sir, you slept your quota for this week, it seems. Your 7 hours of sleep.
Yeah. Actually, I slept yesterday. I wait for 4 or 5 hours. Actually, I haven't slept for last 3-4 days. Anyway, so now I will sleep for next 2 days. I'm going to sleep on. So I'm going to a very remote place. Okay. Anyway. Okay, let me finish this together. You can then keep on solving question at home from the book you have, the PDF. In screw gauge, okay, there's something called zero error. You know what is zero error?
Yes.
It is like you haven't made any measurement, still you are getting some reading. Okay. So there are two possibilities. You haven't measured any, you haven't done any measurement, and the vernier scale is here. So when you start doing the measurement, you have to open the vernier scale. You will try to move this way, isn't it? So even you're trying to open, this much movement will give you zero answer, isn't it? So this is like the lost answer, isn't it? This is the lost answer. Hello.
Yes, sir.
So this is, let's call the zero error. How to represent this? Some name. Let's call Z. Oh, that's nice name, Z. So Z is the measurement which is we should add or subtract in the actual answer.
Add, sir.
Add.
Yeah, because see, this is, if you move it backward, then you will meet the zero. So while you are at no reading, practically you have read something. And what you have missed is the Z value. So that's why the actual reading will be how much here? So now the reading we can attach the main scale reading plus vernier scale reading plus.
Mirror.
Generally, we don't add these two separately. We just add the division here. So let's say you can name it some division. What you want to name it? There's the KZ division is coinciding with 0. And now you know the kth division is coinciding with some random division of the main scale. So the reading is main scale reading plus K plus KZ into least count. I hope this is understood.
Yes, sir.
Like apart from K, you have to also add KZ. Okay. So this is called the reading, and the other variety is this. Okay, when I will solve question, then only I know you will understand what is exactly happening. But anyway, now when you are making no reading, the 0 is here. It is showing some reading which is not actually present. So what we have to do here? Subtract, right? So R equals
Yes.
to main scale reading plus K minus KZ into the least count. I hope this is clear. Okay, done. Done with the 0 error. Okay, I think it will be too much. The screw gauge quickly. So in this case of screw gauge, this is the circular scale. This is the main scale on which to slide for sure. And then we have the datum or the reference line. Only remember one thing, common thing. And what you need to remember is as you turn anti-clockwise, it will open. This will open. So it will move backward, correct? And this will close and will move forward. Okay, and forward means you will go back and connect with the other, the end will, what we call end will here. Something like this. Okay. Something like this. Okay, a simple. And then this is 0. So you will read the 5 here, 10 here. And if it is, let's say, total division is 50. So what will read here? 50. So what will read next? 45. What next? So let's say we have 2 types of division. Now, as you scroll backward, as you open it, you will start seeing the number on the which scale? Main scale. So the main scale will reveal the number because it is generally a metallic case, you can't see it. So as you open it, you can see the number 1, 2. So what you can't see here, the third and onwards, right? So if you can see 2 here, then you can say what is the main escalating here?
2.
Main scale is 2 AM, right?
Yeah.
Now, I mean, to make it general, I can say N. So, okay, I'll do it separately. I hope you understood what I'm trying to say here. This is 2 AM, but to make it a general statement. So, if you can. So let's say you can clearly see a number N. So what you can't see? Next number, right? So what is the main scale reading here? Main scale reading is NAM. I hope this is clear. Okay. And let's say with the datum, so they don't try to only do the datum, they draw something more. But with datum, let's say some number is coinciding. And what is coinciding, you have to read. So we have the circular scale in which you have to read something. So let there be n divisions on which scale? Circular scale, which means you have n carvings on the circular scale. Okay. So if you move one rotation, how many cuts will cross this datum? N cuts will cross the datum, isn't it?
Yeah.
And as a result of this rotation, one complete rotation will take the slider backward or forward, depending on whether I'm opening or closing. Okay. So we have something called pitch length. What is pitch length? So pitch is a very common term. Which it is called the linear displacement per rotation on the main scale. Linear displacement of circular scale over main scale per rotation. I hope this is clear.
Yes, sir.
So what is the smallest displacement we can measure? So see, you slide P unit.
P by N.
Exactly. You slide P unit. Okay. If you make N complete, I mean, one rotation, which means N cut will pass the datum, then you will slide by P. So what is the displacement per cut?
P by
The
N.
two yeah, P by N. So that's called the least count. So the least count here is the pitch upon number of division on the which scale?
Circular.
Circular. Okay. So this is the least count. Okay. This is the least count of screw gauge. Understood? So now how we make the measurement? It's now even easier to understand from the vernier caliper point of view. So the measurement is simple. Let KCth means the kth division of circular scale. So KCth division on circular scale coincides with any division of main scale, any division of main scale. I'll tell you. They don't only see the datum, but they also draw some lines above datum, below datum. And you have to just check which line is matching, whether datum line matching, above line, this line. If any line is matching, just read that value. So that KCth division of the circular scale coincides with any division of the main scale. So what we can say? Tell me how to read this extra. So again, how to find this X? Any guess?
K into P by
Use
N.
the use the linear equation. I mean linear what you say? Unitary method. You travel P for one rotation, isn't it? So n division is equal to P length. So what is okay like this? If n division is P length, so n division is equivalent of P translation. So what is the translation per division?
P by N.
So if you want to if you want to only pass the k divisions,
P by N times K.
okay, it's that simple, and that is why this is nothing but the X. Do you realize this?
Yeah.
Yes.
See, the k division will only let you travel X value. Okay, because n division will let you by travel P value. So less than n means less than P also. So this is the answer. So we have this is basically called K times least count, right? It's the same definition. Because by definition now the least count is P by N. Isn't it? So you can clearly see
Yes.
the circular scale reading is K times LC. So what is the reading as a whole? Main scale reading plus KLC, right?
Yes, sir.
That's why this is how we write the reading. Then again you can do the error. So including 0 error, the reading will be MSR plus KC plus minus K0 into LC. That's it. And you know how to do this. So let me tell you, okay, tell me, okay, what is the right way of doing this? If you read without measurement, if you read here, let's say this, there is total of, this is interesting. So let's say n equals to 50. And what you see here is 45. Tell me, is it more tightened or it is loose? I mean, what is it? It is loose. If 45 is here, where will be 0? Above or below? Can you guess? And this is without reading. Without measurement. If you see 45, where is 0? Above the datum or below the datum?
Above.
Exactly, it is here. So what you have done, you have moved clockwise actually, extra, isn't it? So you have closed it more tightly. Do you realize this? So you haven't stopped at 0, rather you turn further and you can see 45 is there. So how much extra you have made the turn? Tell me.
5 divisions.
5 divisions. So here the KZ is 5 actually. So when you study, when you read the bigger number, subtract from the maximum value, and then you will understand what's the extra reading.
Excuse me, sir.
Yeah.
Could you repeat this part from the starting, like from where we turned the
Yeah, you can
circular
just
scale?
just look at this. Ideally, when there is no reading, the 0 of the circular must be on the datum,
Yes.
and 1 must be inside. So you must match with 0 somewhere.
Yeah.
So now instead of okay, the 0 is not, if 0 is not matching with the datum, rather let's say is it 50? No, this is 45. I think this is the wrong plan. 40. So imagine. So imagine 0 is above the datum. So which number will come close to datum?
45.
The bigger number?
Yeah.
Which may be 49, 48, 47, 46, 45. Isn't it?
Yes.
So when you see a number, because here n is 50, and when you see a number which is more than 25, I mean that won't be happening here. So when this will happen, when you see 45, when you tighten the screw more than normal,
Yes.
you have closed more tightly. That's why the 0 has gone up, no?
Huh.
And 45 has come to the datum.
Yeah.
So if the number you're reading before the measurement is made is more than half, it's let's say you're reading 45. So we have tightened this more. So in this case, the 0 error we have to add or subtract. If you're reading 45, should you add 0 error or subtract 0 error?
I subtracted, right?
No, you have to add, no? See, without measurement, you're inside. So when you start opening the valve, you have to first move by 5 units to make it 0.
Okay, yes.
So anyway, you have to move 5 extra, right? So even there is no, let's say if this 0 is there, it means you're not reading anything, but you have moved by 5 turns, right? 5 cuts.
Yeah.
So here the 0 error will add up, no? Here this is KC plus KZ. And if you read a number five here.
We'll
So 5
subtract.
means someone has opened already.
Yeah.
Without measurement.
Hmm.
So it is, of course, the jaws are touching, but still the number is 5. It's a manufacturing defect. So what you can see, the K will be KC minus KZ, right?
Yes.
And then the formula is this. So have you understood the formula? How to use the formula?
Yes. Understood.
This is the end of error analysis. We have done every question, every concept which you need to know. And then I will encourage all of you to solve the PDF. And before the next lecture, I will discuss the doubts. Okay. So before the next lecture, finish it so that we can discuss.